We are looking at slope-intercept form today. Go ahead and put your name on here if you haven't already. It is currently first hour. And today we are moving from an equation to a graph. So I'm going to give you an equation. You are going to create the graph. What we need to know about slope-intercept form is slope-intercept form is y equals mx plus b. M is our slope. So m equals slope equals, let's go ahead and write down that rise over run right. Because when we are actually graphing it, that's what we're going to use, is the rise over run. Okay, B, does anyone remember what B is? Our y-intercept. Yep. Is that what you said? Yeah. Okay. B equals our y-intercept. Specifically our y-intercept, which means our intercept on our y-axis. What does the word intercept mean? Okay, so intercept is pretty similar to intersect. What other context do we use the word intercept in? Like what other pieces of life have you heard the word intercept? What? Are you thinking of an intersection? Yes, so that's where two roads cross is an intersection. Okay, think football. What does it mean in football when you get an interception? Guys, what's an interception? Okay, so like someone on the other team catches it, right? So if Jack is throwing it, someone on his team, and then someone on the other team catches it. So do we intercept that path? So intercept, intersect, very similar words. I assume they have the same root word. It is where we are going to cross. So put a little note here. There's not space in the box, so I'm just going to put it over here. Where we cross the y-axis. So it's where we cross the y-axis in the math sense of the word. Alright, we've got a few little notes here about logistics. If a slope is not already a fraction, so we are used to slopes being fractions because we do rise over run, rise over run. If we do not have that bottom of the fraction, you can always put it over 1. So a slope of 2 is 2 over 1. A slope of negative 7 is negative 7 over 1. So you can always put it over 1. If there is no slope right there in front of your x, you can put an imaginary 1 there. There's a slope. So y equals x is y equals 1x. And then the last thing is if there's no y-intercept, if there's no plus b, if we are adding nothing, what are we adding? What is nothing? 0. So when we are adding, if we are adding nothing, it's 0. When we're multiplying, if multiplying and not changing it, that's going to be 1. Okay, your directions on these. List the slope and y-intercept out, then graph the equation. So we're going to go through, we're going to pull out the slope, pull out the y-intercept, and then we're going to talk about how we graph these. So this first one we've got y equals 4/3 x minus 5. Our slope is the coefficient on x, so it is 4/3. When you write down your slope's always just going to be a fraction. It's never going to have the x with it. The x is not part of the slope. The x is the variable. And then our y-intercept here, since it's minus 5, our y-intercept is negative 5. Okay. Any questions about that? Okay, so we are ready to start graphing then. We start graphing on our y-axis. So this is our y-axis. We go to our y-intercept. That's, the computer's being really slow. We can think of that as our starting point. So negative 5 down here. Put a dot there. So for today, think of your y-intercept as your starting point. From there, we want to graph our slope. Our slope here is 4/3. So that means we go up 4, we rise 4, we run to the right 3. So we're going to go up 1, 2, 3, 4, run to the right 1, 2, 3. Put a dot there. And then we want to keep going as long as we can. Go up to the right, or go rise 4, 1, 2, 3, 4, run to the right 1, 2, 3. And then I can't fit another dot. You want to make your lines go, you want to put as many dots as you can on your graph. Once you get those, you can go ahead and connect to them. In later this unit, we are going to graph inequalities, and we're going to have to shade above or below this line. 103,643. 103,643. Sorry, it signed me out. So later this unit, we're going to have to be able to shade above or below this line. So we need to make sure that this line goes all the way from edge to edge of our graph. And then next unit, we are going to be seeing where graphs cross. And so in order for them to cross in the right spot, we want to draw as many dots as we possibly can on our graph. Any questions right now? Okay, you do have to connect them. Use a ruler because we are graphing lines. We are not graphing just a bunch of dots in a line. We need to actually graph the line. And then the other thing is make sure you put arrows on the ends because these lines go forever and ever. Hey, I think those are all just the general things I need to tell you. I want to tell you about lines. Let's keep going. Next one we've got y equals 3x plus 2. What is my slope? 3. What is my y-intercept? 2. Awesome. Okay, my slope is not currently a fraction. I can put it over 1. So I can make that 3 over 1. And if you need to do that on that line, do that on that line. If you can remember that your run is always 1, if you don't have one, you can. Okay, so our y-intercept is 2. We're going to start at 2. And then our slope is 3 over 1. So that means we go up 3, 1, 2, 3, right 1. Okay. Can I go any further that way? What could I do then? And to the left. So if I'm going up into the right, if I want to go the other direction, I have to reverse them both. So I'm going to go down 3, left 1. And I can also do that, and I should do that as far as I can. Down 3, left 1. I can do one more. Down 3, left 1. All right. Any questions about those guys? I should connect them. Okay, flip this over then. We got 2 on the back. Guess what we haven't seen yet? A negative slope. Guess what's on the back of this worksheet? A negative slope. Crazy. Hey, we have y equals negative x minus 3. What number, or what is our slope? Negative 1. So there's an imaginary 1 right here. You just have to know that if there's an x by itself, there's a 1 there. So if it's positive x, it's 1x. If it's negative x, it's negative 1x. So that means my slope is negative 1. I need to make that a fraction. What can I put it over? 1. So my slope can be negative 1 over 1. Okay, and then my y-intercept is negative 3. It's minus 3. So I'm going to start on my graph at negative 3. And then my slope, I'm going to go down 1, right 1. Down into the right, down into the right. Okay. I know it's a lot of little teeny tiny dots, but I promise when we get to unit 3, you're going to be glad you're in the habit of doing it. You can also go up 1, left 1. It doesn't take that long. Hey, connect those puppies. And after you graph it, you can be like, oh, does this have a slope of -1? Oh, yeah, it does. Crazy. Does it have a y-intercept of -3? You can check yourself. Hey, last one we've got. Y equals -3/4 x. What is my slope? -3/4. What is my y-intercept? 0. If I am adding nothing here, so I would write +0 there so you know where we got that from. My y-intercept is 0, which means I start right here on the origin at 0, 0, because my y-axis is 0. Okay. This is my y-intercept. Okay, -3/4, so we go down 3, right 4. And then we can't go another one because we don't have another 4 we can go. We can also go up 3, left 4. Right. Connect these puppies. Your graphs on your assignment today are all 7x7 graphs. We use 7x7s. At some point we moved to 10x10s because we need to be able to graph more stuff. But the bigger I make your graph, or like, the more numbers I put on your graph, the smaller the little squares are. But then we can only graph so much stuff on such a tiny graph. But I can only fit so many tiny graphs on a sheet of paper, half a sheet of paper. Okay, any questions right now? Okay, glue these puppies into your notebook. We've got an assignment for you. Our goal is to get it done today on this delightful skinny day. I did not do anything crazy and extra so that we could actually get done with our assignment on a skinny day. It is a skinny day. I'm trying to stop this video, but my computer is moving the speed of...
Is tomorrow Friday regular?
Yes, so skinny and then even odd. Oh my gosh. Stop video. I promise. I'm just gonna bring you... Okay, finally. Okay.